안녕하십니까. AWC 2021 세계 식량 문제를 위한 AI 기술 역할 대담에 참여하신 모든 분들 환영합니다. 미래 농업은 세계 인구의 급격한 증가, 팬데믹에 의한 국가 간 식량 유통의 어려움, 그리고 기후변화로 인한 잦은 자연재해로 인해 식량의 수요와 공급의 불균형이 심화될 것으로 예상하고 있습니다. 오늘 대담에서는 글로벌 식량 생산에 있어서 도전적인 문제는 무엇이며 이를 해결하기 위해 인공지능, 빅데이터, 로봇 등 지능정보기술을 어떠한 역할을 할 수 있는지 논의해 보고자 합니다. 오늘 진행 방법은 먼저 각 연사분들께서 10분 정도씩 발표를 해주시고 이후에 토론을 진행하는 것으로 하겠습니다. 온라인으로 참여하고 계시는 분들 중에 질문이 있으시면 채팅창에 올려주셨으면 합니다. 토론 후반부에 연사분들께서 답변을 드리도록 하겠습니다. 오늘 토론을 위해 두 분의 연사를 모셨습니다. 제가 조금 연사분들을 자세히 설명을 좀 드리겠습니다. 먼저 이스라엘 Agrematch사의 이얄 벤-찬옥 이사님입니다. 벤-찬옥 이사님은 몬산토와 바이엘의 전 사업전략 이사셨으며 뷰로직스 공동 설립자이며 CE셨고 그린 노블레이션 랩스 공동 설립자이자 CEO를 하셨습니다. 농업 관련 기업에서 다양한 경험을 가지고 계십니다. 다음은 와닝겐대학교 거트쿠트스트라 교수님이십니다. 교수님의 주요 연구 분야는 컴퓨터 비전과 로봇의 농업 응용입니다. 와게닝대학교의 에그리푸드 로보틱스 연구센터의 참여 교수이시며 네덜란드의 대규모 농업용 로봇 연구 프로그램인 플렉스 클래프트 코디네이터이시기도 하십니다. 먼저 우리 발표부터 시작을 하겠습니다. 먼저 이얄 벤-찬옥 이사님께서 발표를 먼저 시작해 주시겠습니다.
Professor Lee, was that a question to me because my Korean is really rusty?
Oh, I'm sorry. Maybe you cannot hear the English translations?
No.
Probably you can select some Korean language and you cannot see Korean language or English anything? Okay, I'm sorry. So, but anyway, we will start first. Would you please present for 10 minutes?
Okay.
Yeah.
Thank you very much, Professor Lee and Dr. Kootstra, and everybody that invited me here today. I'll try to squeeze in very short 10 minutes a little bit of agriculture and challenges in agriculture to the audience who I presume are more interested in AI and computing, and that will give you something to think about, I hope. So I'm Eyal Ben-Chanoch. I'm the executive chairman of Agrematch. It's an AI company from Israel that we focus on solutions for agriculture. Next slide. So a little bit about what we're talking about food and ag in this particular session, and where food comes from. So food, basically, we have three sources of food for us: plant-based meat and seafood. And what the world today is mostly farming. We do farming because it's not very effective to go hunting or to go fishing. So even you have a little bit of statistics here, and all my statistics are from the FAO. It's the UN Statistics Organization for Food and Agriculture. So there's a big use of our land for making crops, and even fisheries, which was the last hunting, so to speak, a practice. Now farming of seafood way surpassed what we do for as fishing. Next slide. I cannot change the slide. So the nexus of the resources in the world today that we're using to make food is in much more complex and bigger map of water, energy, and food. It's always the balance between them. And if you look how the drivers from all sides of the equation, it brings us to, in agriculture, we have 5 main, to create agriculture, to support farming, we have land, water, energy, capital, and labor. And all 5 of these have to play together. And I'm going to talk a little bit about land and water just to illustrate the challenges. And Dr. Kootstra, I believe, will talk a little bit about labor and others that you do with automation and robotics. Next slide, please. So land and water and population growth. I think the most incredible slide here or graph here is about how we use land. So if you look at the history of arable land use, you can see that it's even when population growth continue to grow, it's flattened out somewhere in the mid 20th century. If that's the top left graph, and it's not because we don't want more land, it's because there's no more land. And this is pretty much flat, and water looks about the same. Water used today is about the same. We got to the maximum, and if you look at the green part of the graph on the bottom left, you'll see that the vast majority of water goes to agriculture. It's not for drinking, it's not for industry, it's primarily to agriculture. And without these two, land and water, we cannot farm and we cannot make food. There's urban land and population growth. You can see that per capita, the amount of land to produce food for people declined dramatically. Next slide. So what we're doing about it and what agriculture will look like in the 21st century. So we need to produce more food for humanity with basically the same or even less land and water. So we need to increase efficiencies, and the key factors here are the farmer himself will have to practice, to be educated, and to use technology. Crops need to be more with elite seeds, meaning you have more yield, more resistance to pests. Systems that will help irrigation, save water, automation. In all of that means investment. And what Agrematch is doing is in the risk management part of it, which is the crop protection. About 40% of the crops on average is lost to pest and disease. And you can understand that nobody can today do agriculture without protecting the crops, and you need products to use as crop protection and to elevate the yield that come from the field. Next slide. Agrematch, our contribution, and maybe that's the what I'll focus for the rest, is what we do about it. So Agrematch started about 4 years ago with the idea of to address fundamental needs for new products in agriculture. Existing products are getting old. And not all because they're stealing, but because there's resistance of disease and pest developing. This is biology. And you need new materials, new compounds to be effective in the field, whether it's for a disease control, weed control, or insect control, which are the three major pests that are the three pillars of the risk management in the field when you come to crop loss. Agrematch developed an AI system to browse and identify novel functional compounds that will be new products. Products in agriculture take a long time to develop, and there's a great need for new compounds, new chemicals, new natural chemicals or synthetic chemicals to make new products to replace or supplement the existing one in order to elevate the yield and to reduce the risk of losing crops. The company now have generated a pipeline of new plant protection candidates, and we're working already with all kinds of companies to try to take it further and develop that to take it to market. And the way we do it is by using data that associate with existing activity. We use about 1.5 billion compounds that we have in our database, and we browsing this phenomenal space using AI and machine learning technologies and modules that we develop specifically for that purpose. It requires obviously very equipped people, and we run a significant machine learning algorithms on the cloud in order to get these candidates. The drawing here on the bottom shows a little bit about a process. It's obviously you cannot get to it in 10 minutes, which I think, next slide, I have about 15 seconds to summarize. And so in the take-home message is food security is the future, and agriculture food production needs significant efficiency boost. And my belief is that AI will play a major role to resolve the solution that we need. Thank you, Mr. Lee.
Okay, thank you, Mr. Eyal Ben-Chanoch. Okay, can you see the interpretation?
There? I could see the slides.
Can you see the interpretation button in the bottom? In Zoom window, you can see the interpretation button, and you can select the language, Korean language and English. You cannot see?
No. Ah, yeah.
How about Professor Kootstra? Can you see the interpretation button?
I can.
Okay.
I did. Thank you.
Thank you. Okay, yeah. 지금 이사님께서 식량 증산을 위해서 주요한 인자들과 그리고 인공지능을 이용한 어떤 작물 보호제 농업 합성물에 대해서 좀 간단히 설명을 해주셨습니다. 예, 다음은 거트 쿠트스트라 교수님께 발표를 부탁드리겠습니다. Please turn on your mic.
Yes. Okay. Sorry. Yeah, I could not unmute myself, but I can now. Okay. Can I change my slide? Yeah, I can change my slides. Great. Just testing that out. Little sneak preview there. Hi, welcome. My name is Gert Kootstra. I work at the Wageningen University in Research. I'm very honored that I'm here, that you invited me to join AWC in Busan. I would like to talk briefly about agriculture, some of the challenges that agriculture is facing. And Professor Ben-Chanoch already went through that in a lot of detail. And I would like to point out that we can use AI and specifically robotics to alleviate some of these challenges. Now, if we look in challenges, just to basically kind of sum up what we've already seen, then, well, the global food production is facing a lot of challenges. The first point, as we all know, more and more people are getting to this planet, needing more food, needing more feed for the animals, needing more fuel for their cars, needing more fibers for their clothes. So agriculture needs to produce a lot more. Well, it's already producing a lot currently, but in the next decades, that should increase roughly about 70%, some estimate. But on the other hand, there's scarcity. We've already seen there's a lot of scarcity on land. Land use is already optimally used. The scarcity on water, also fossil fuels are running out, or we don't want to use them anymore. Fertilizers become a problem. And there's a scarcity in human labor, which is a little bit of a contradiction, because more people get into this planet, but less people are willing to work in agriculture. That's because agricultural tasks are usually very repetitive, quite dull, but also very hard and working in a harsh environment. So people don't want to do these type of jobs anymore. And thirdly, there is a huge impact of agriculture on the climate. Right? A lot of greenhouse gas emissions, waste, the chemicals, and diseases. So basically, to sum that up, we need to produce more, but we need to do that with less impact, less resources to use. Now, there are many different solutions needed to get there, but one thing that we believe in Wageningen is very important is that we change our agricultural system. We currently have large monoculture systems where we have big acres full of single crop, all potatoes, all wheat, which is really stressing the biodiversity. So we would like to move back basically to the old system of farming in a more ecological system where we use biology itself to make a more robust and resilient system. So we'd like to go to these mixed cropping systems. But there's a big problem. We want to do that because if you move to ecological farming, and a lot of farmers are doing this, it means that you need to now rely on human labor to do the work. Right? You cannot use chemicals anymore to kill your weeds. This all needs to be done manually. And it's difficult to find these people, as I already mentioned, because of the scarcity. Right? So on one hand, labor scarcity. On the other hand, there's a huge cost for labor involved as well, which makes these more biologically grown crops much more expensive. So what can we do about it? Well, we believe that we need to support these type of ecological farming systems using robotic systems, using AI technologies, because that can enable us then to do this ecological farming in a sustainable way, but also in an affordable way. We can do precision agriculture, robots applying the right amounts of water, chemicals, fertilizers at the right location to prevent waste of those resources. That improves the resource efficiency, that reduces the pollution a lot, it reduces waste. If we also use AI technologies in the post-harvest process, we can also reduce a lot of food waste by making sure that we harvest foods at the right moment in time when there's demand. We don't have to throw it away when it's in the supermarket and not sold. And we can solve the labor scarcity problem and reduce costs, and overall improve the quality of food production, right? Well, so this is a large problem, of course. So why are these systems not there? Well, we are in Wageningen, but also other research facilities, companies all around the world working on these technologies. And you can take it all through the food production chain, from inspection of seeds to robotic use of transplanting plants, scanning and monitoring the crops in greenhouses on the field, automatic harvesting in orchards or on the field, in greenhouses, and also in post-harvest we can do these inspections. But we see that there's different level of robotization, automation in agri-food. If we look, for instance, in the food packaging industry, packaging cookies, bags of potato chips, etc., we see that this is almost fully automated nowadays. We have these robots that are very efficiently, they can package your products. If we look at something like poultry, for instance, we see a mix. There's automation in place, well, conveyor belts, some robots doing some tasks, but we also still need to rely a lot on human labor to deal with the variation of these products. And if we look at the other end of the spectrum, greenhouses, for instance, we see that everything basically still done with human labor because this environment is too complex. And why is that so complex? Well, there are some challenges. Sorry. Right, so we see that there are, I'm not sure if these videos are starting, but we see that there are some companies, also research facilities, ourselves is one among them, developing robots to work in robotic greenhouses. So we are making steps, but these robots are not commercial successes yet. And that's mainly because there are some technical challenges. And the first challenge is the challenge of variation. This is a picture of tomatoes, and you see that every tomato is completely different. There are different cultivars of tomato. Even within one cultivar tomato, you will have variation in the appearance, color, size, shape of these fruits, right? In addition, in the greenhouse or on the field, there's variation resulting from the environment, weather influences. There might be direct sunlight, there might be clouds, can be rainy, moist, etc. This causes a lot of variation for robots to deal with, to handle with. There are differences in cultivation systems. Right? The farmer might produce its crops in a different way. And for robots to really be successful and economically viable, they should do not just one single trick, one single task, but they should be able to work on a diversity of tasks. So variation is one key challenge that we need to tackle. The other challenge is the challenge of complexity. If you look in the greenhouse like this is typically how it looks like. Very cluttered environment, a lot of objects, which also causing a lot of uncertainty. We cannot see everything. The robot cannot see everything. So there's a lot of missing information. We need to deal with that. And last but not least is safety aspects. Robots should be safe to the products that they handle, which is currently often not the case. So products can be damaged because of the grippers that we have, the interaction that the robot makes with the environment, but also should be safe for humans to collaborate with robots in the same environment. Right? And I think AI can help us a lot by tackling these challenges. So we look at variation and we get some inspiration about our own brain. We see that we have very robust perception. Humans can deal seemingly effortlessly with that variation. And currently, deep neural networks are getting, well, maybe not yet on par with human perception. They're getting better and better to deal with variations. So we have some means there from AI to deal with variation. There's incomplete information, conclusions. If we look at the human being again, we see that perception is not a passive thing, it's active. This is our eyeball. There are muscles directly connected to our eye. We constantly move around when we look at the world. So we need robotic systems, and we have robotic systems that can actively look around. They can plan their own new sensor information in an active way. But we need new methods to do this in a very efficient way. And last but not least, the safety issue. Again, the human hand as an example. We have soft actuation. We can handle products without damaging them, but still robustly grasping them, manipulating them. So here we need the research in the domain of soft robotics so that we can have a safe interaction with the products, but also with the environment and humans working in that environment. So if I sum this up, there's a huge potential of robotics, agri-food robotics, to alleviate some of the big challenges in food production. But there are some major challenges that we need to deal with to really make these systems work robustly in the complex environments. But I feel that AI offers a lot of opportunities already, but hopefully also in the future, more and more of these opportunities to fuel getting solutions to these challenges. And this is something that we are working on, not only in our organization, but worldwide, with a lot of collaborations with other institutes and companies. And hopefully this will give us means to deal with the challenges that I presented. Thank you very much.
예, 쿠트스트라 교수님 감사합니다. 예, 농업 분야에 있어서 로봇의 필요성에 대해서 말씀해 주셨고 기술적인 문제점에 대해서 언급해 주셨습니다. 아쉽게도 우리가 로봇 동영상을 볼 수 없어서 조금 아쉽습니다. 나중에 유튜브에서는 그게 좀 잘 실행될 수 있었으면 좋겠습니다. 조금 이제 디스커션 하는 시간으로 가보겠습니다. 두 분 연사님께서도 발표에서 잠깐 언급하셨지만 지속적인 글로벌 식량 생산을 유지하기 위해서는 여러 난관들이 우리 앞에 놓여 있습니다. 이러한 난관들에 대해서 좀 더 기술적인 부분에 초점을 맞춰서 좀 더 구체적으로 말씀해 주시면 좋을 것 같습니다. 아쉽게도 저희들 시간이 충분치 않기 때문에 이번 질문에 대해서는 간단히 답변해 주시고 두 번째 질문에 조금 더 많은 시간을 이렇게 할애할 수 있도록 하겠습니다. 먼저 이얄벤찬옥 이사님 부탁드리겠습니다.
Thank you, Professor Lee. I think there's a big difference between what's happening today and what will happen tomorrow, because today we need to feed 7.5 billion people, more or less, and in 20 years or so, we need another 2 billion people, and that different type of problems. So today's problems, and I am not sure that AI will deal with them immediately, are distribution of food and distribution of resources. There is enough food in the world today, and still there are people go hungry to sleep. Because in one place there's a lot of waste and loss, and in another place there's not enough. And it's not all foods, such as grains, can be transported safely in time because of the cost. It's really hard to move around a certain fruit, vegetables, and others around the world in a good way. I think that AI supports the supply chain tremendously, and there's a lot of opportunities over there for AI, but this is not proper the creation of the food, but moving it around. The same actually applies to water and land, that they are not distributed equally. It's not where you need them. You'll have the population that require the food, and there's a lot of work done over there. In the future, the problem is completely different. As Dr. Kootstra said, we need to make more with less. And that's a different challenge altogether. And I think AI will play a huge role in everything. First of all, it's amazing work that Dr. Kootstra and his colleagues are doing in resolving the actual production and harvesting. But there's a lot of work on creating new varieties using AI. And what we do in Agrematch is a new product. I hope I answered your question, Professor Lee.
예, 감사합니다. 쿠트스트라 교수님 의견은 어떠신지요?
Yeah, I think Dr. Ben-Chanoch points out to some very challenging topics, which are also maybe more politically almost, right? How do you divide these resources and the production of food in an equal way? I'm not really in the position to say a lot about this. Right? I see that there's definitely a challenge. So I'd like to narrow it down a little bit more to the uses of robotics to at least help out in some of the production issues and challenges that we have. And then I'm very excited what happened in the past, let's say 5 years or so in AI. We've seen a huge, basically a revolution in computer vision, or maybe also in audio processing. So basically in the interpretation of sensor data by the rise of these deep neural networks. Well, I mean, it's used all over, right? If you have your camera, it's used to recognize your face. Facebook uses it to filter out photos and messages, automatic face detection, etc. But in agriculture, we can also use that. We can surf on all these developments that are done in the tech sectors to make our robots much more robust and deal with this complex environment that we're looking at. And then, I already showed that robots can help out in replacing some of the human labor. It can become much more efficient in using all kinds of resources. But I didn't talk about that, but it connects a little bit to what Professor Ben-Chanoch is saying, is that we also need to breed crops that are more resilient, need less resources. And also there, image processing robotics can help out a lot. We see that currently, the current practice is that humans look at the plants to try to estimate if this plant is healthy or not, which really limits the amount of data that we get. We call this the phenotyping gap. Right? We have a lot of sequencing data, a lot of information about the genome, by the DNA of the plant, but we only have very limited information about how the plant develops and how it reacts to all kinds of environmental factors. We are using camera technologies, deep learning networks to identify plants, to try to represent how healthy, how well the plants are doing in their environments, so that we can automate also that process of breeding and speed up the breeding process to get better crops faster. So I'm very positive about what AI can do, but it definitely is still a lot to be done as well. So I hope we can inspire some people to use their brain capacity to help us out.
예, 고맙습니다. 사실은 이제 두 번째 질문에서 우리가 인공지능이랄지 빅데이터 로봇들이 우리가 현재 직면해 있는 여러 난관들을 어떻게 극복할 수 있는지 좀 더 구체적으로 질문을 드리려고 했었는데 두 분께서 아마 그 부분까지 같이 말씀을 해주신 것 같습니다. 그래서 두 번째 질문에서는 오늘 여기 온라인으로 인공지능 빅데이터 로봇 관련 지능정보기술 기업체에서 많이 참여하고 계십니다. 그래서 이러한 기업들이 앞으로 농업 분야에 진출하기 위해서는 무엇을 조금 어떻게 지금부터 준비해야 되는지 거기에 대해서 여러 가지 의견을 주시면 감사하겠습니다. 먼저 이얄벤찬옥 이사님 부탁드리겠습니다.
Thank you for the question. It's first of all, it's a good question, and second, it's I hope, like Dr. Kootstra said, we will inspire some people to do that, because it's actually looking for our next generation's food supply. I'm a serial entrepreneur, was on both sides of startups and corporate, and I think first of all it's to get domain expertise. We see startups that are going into agriculture, or they understand that the problems are interesting and important, and they want to do that, and they come from a background like myself of computer science and mathematics, and they really want, but they don't have the domain expertise, because agriculture is complex, a very dynamic field that is, if you got the sense of the amount of different moving things in creating food, it's tremendous effort. So for companies that want to go into this field, I think they need to talk to farmers. I think they need to have people that actually understand farming, and then to address some of the acute problems that, or the challenges that we have there. It takes a lot of dedication because it's very different than to develop an app for an iPhone or for an Android, because to grow plants and to test them and to see how you develop takes time. So it takes a lot of dedication and patience, but it's very, very rewarding. Thank you, Professor.
예, 고맙습니다. 쿠트스트라 교수님 의견 부탁드립니다.
Yes, it takes a lot of time and dedication. That's also what I see. So there are a lot of startup companies that I know here in the Netherlands, Germany, that try to get into this field, but after 1-2 years they go bankrupt. I think it needs a larger effort than that. We have had a few successful commercial products coming out of our research, and it takes a company easily 4 or 5 years before this is really a stable product. Once, I mean, we can show in our lab that things work, the proof of principle is there, but then to really make it robust really takes time. So I think that these companies need enough funding to take this 3-4 years to really develop a good product. So that's one thing that I think it's important to realize, and I hope also that the bigger companies really step into this game, like the John Deere, and they are doing now. They are now trying to taking over some of these startup companies to do that. But I think that in some sense maybe relatively late in moving into this new industry. The other thing, if I look at how software development in Google, Facebook is going, they really are very open in sharing resources. They don't share everything, but they share a lot of their code, they share a lot of the data, which is progressing the development. And I don't see that currently in this agricultural robotic applications. All companies, they gather their own data sets, they label their own data sets, which is a huge effort. And AI can offer a lot, but it needs also a lot of data. These companies, they spend all their money, all their budget, basically on annotating data, and then hopefully they get a system running. But there's another company that's basically doing the same thing. They annotate similar images, they put in the same amount of money, which is really a waste of time and resources. So I hope we can get to a more open structure where also companies start sharing some of their knowledge. And I think in this case, especially data is what needs to be shared. Thank you.
I concur.
예, 교수님 감사합니다. 온라인으로 질문한 내용을 조금 질의드리겠습니다. 대부분 지금 AI가 우리 기술이 발전하고 있는데 AI를 실제로 농업에 적용하기 위해서 우선적으로 해결해야 될 과제가 무엇인지, 이게 첫 번째 질문이고요. 두 번째 질문이 AI가 주로 대규모 이렇게 농업에서 적용되고 있는데 이게 소규모 농장이랄지 소규모의 농업에 적용하기 위해서는 조금 어떠한 문제들을 우리가 해결해야 되는지, 이 두 가지 질문에 대해서 좀 답변을 부탁드리겠습니다. 먼저 이얄 벤-찬옥 이사님 부탁드리겠습니다.
First, I apologize. I'm working. I'm at home and my dog just barked. Thank you for the question. I hope I got it right. I think that the question was about how AI can accelerate proceed in agriculture. Is that correct, Professor Lee?
예, 맞습니다.
Okay. So I think there's so many layers in agriculture and food production that AI can accelerate both in the production and in the supply chain. Professor Kootstra mentioned imaging getting a lot of use a more user. And for example, in the supply chain of food, quality of food can be determined pretty good, even though there's variation, and variation are some of the quality measures. Today with imaging and AI, you can sort fast and test the quality of food when it is in the supply chain. Actually, this is not a new technology, it's new to agriculture maybe, but companies like Amazon mastered the AI use within the supply chain. They're doing that very well, and we need to learn and put it to work in agriculture as well. Improving to tackle the big problems. Today, there's waste and there is loss. Loss is when you grow the plants and there's between 20 to 40% loss to disease and pest. And if you improve first the tools that we give the farmers in protecting the plants and the tools to spray or apply these tools to the field, that will create a much better environment for plants and will reduce the loss. Loss is so big that if we cut the losses today by 20%, we did a tremendous impact on the food supply chain. There's many applications along the food production systems, and a lot of opportunities for AI for improving, and there's a lot of good people working on that, but we need more. Thank you, Professor Lee.
예, 고맙습니다. 쿠트스트라 교수님 그 질문을 다시 한번 드리겠습니다. 지금 AI랄지 첨단 로봇 기술들이 주로 대규모 농업이랄지 대규모 자본이 투입되는 곳에 집중적으로 사용되고 있습니다. 이러한 기술들을 소규모 농장이랄지 소규모 자본이 투입되는 농업에 적극적으로 활용하기 위해서는 어떠한 방안들이 있을까요? 여기에 대해서 답변해 주시면 감사하겠습니다.
Yeah, thank you very much for the question. Yeah, for small-scale farmers, I think what is key that we have systems, and I focus a little bit on the robotics, but of course there are more aspects where AI can be used. But if we look at the robotic system, I think it's very important for a small-scale farmer that this robot can do is versatile, that it can do multiple tasks. Because of course the investment of buying such a robot might be substantial. If it can only do one trick, if it can only harvest your potatoes automatically, well, that is 1 week in a year that we need that task, right? So then it's going to be a very expensive robot. But if it can easily deal with different type of problems, maybe similar to how if you buy a tractor, you can buy different implements. The tractor itself is a very versatile system. It can do many different tasks if you apply the right tools on it. Something similar needs to be done in robotic systems. So perhaps you need to shift with your tools on the robotic system. But that also means that AI should be able to interpret the environment and come up with the right decisions for all these different tasks. So to deal with that versatility, still a lot of research that needs to be done in this respect. I think I would say that would be one of the key challenges if you want to have this system operating in smaller farms. But I hope that answers your questions more or less.
And if I can add, because I missed the question, Professor Lee, before, I think cost. Smallholders, farms need, they don't have the capital that big farmers have. And I think the AI and software system in general have the potential to reduce cost.
예, 답변 감사합니다. 저희들 시간이 많지 않기 때문에 오늘 토론을 정리하는 의미로 각 연사분들께서 간단히 최종 하시고 싶은 말씀, 미래 농업에 대해서 좋은 의견을 주시면 좋겠습니다. 죄송하지만 1분 안에 조금 의견을 제주시면 감사하겠습니다. 먼저 이얄벤찬옥 이사님 부탁드립니다.
Thank you, Professor Lee. I think that we try to show that there's a really big challenges and really big hurdles to overcome in production of food for humans. And they will grow, the challenges will grow, but I'm extremely optimistic. And I really think that AI will play a huge role in solving these problems. I think we have an opportunity now to participate in something really exciting and really important, and this is to the audience. If you want to pick something that will make an impact on the world, this is it. Thank you.
예, 고맙습니다. 쿠트스트라 교수님 부탁드립니다.
Yes, I could not agree more. So AI is not the only solution to the problems that we're facing. We probably also need to change our diets, for instance, go more plant-based, less animal meat. But AI will play a large role in solving the future challenges in food production and making sure that we all have enough food, fuel, fibers for our needs. But that means that we need people with AI skills working in this domain. And I think currently still a lot of people are not realizing how interesting this domain is to work in, to do your research in, if you come from an AI background. And I hope with this type of workshop, we're making people aware of this. It's really an exciting field. We need you, and you can really make a contribution, as Professor Ben-Chanoch already mentioned. So this is it. This is the field to work in. Thank you.
예, 두 분 연사님 좋은 의견 감사합니다. 식량 문제는 인류의 존속과 직접적으로 관련된 문제라고 생각을 합니다. 이러한 문제를 AWC 2021에서 논의할 수 있는 기회를 주셔서 감사합니다. 참여하신 두 분 연사님과 온라인으로 함께하신 모든 분들께 감사드립니다. 이상으로 토론을 마치겠습니다. 감사합니다.